Yeah, go on, go on.
Hello?
Go on, go on, go on. You can speak. Hello, you can speak. Can everyone hear me? Okay, I think his network is having issues. Okay, so yesterday we started with joins, and we looked at the inner joins. We also looked at the left joins, the right join, and we stopped at the cross join. So before we continue with the cross join, or before we move to the full outer join, yesterday we were sharing on the left join, and we could not really um, piece together a question that reflected what we wanted to see about the left join. We could not see those null values. That is when you bring tables from the left and you bring tables from the right using the left join. We could not see a perfect example that showed what we're trying to see. Are we following? Okay. All right. So I think there is a question that we can just quickly look at. Still under the left join. Just one question to help us see what we're trying to share yesterday. We're trying to establish something, but then we're finding it difficult to come up with a question. So quickly, let's just look at one last example on the left join, and we'll move on with today's business. So I'll just say last example on the left join. Okay, so the question is show those tracks that that have not been purchased. Show those tracks that have not been purchased. Okay, so from
Mr.
the
Mimi, please, can you zoom out a little so that we can see?
okay, is this clear enough?
Okay, it's okay.
Okay. So show those tracks that have not been purchased. So it's quite straightforward. So we have our tracks table in mind first. So let's see from tracks or track. It's track on my own. Okay, I didn't put E. Okay. So from my track table, I have the track ID, I have the track name, I have the album ID, the media type ID. Okay. So let's see invoice. Let's see if we have. Let's check invoice first if we have something to join them. Okay, invoice, and track. So there is no information on track here. Let me check invoice line. Let me check for the invoice line. Okay, we have the track here. Okay, we have track. So we'll be using the track table and the invoice line. So like I said, the example is just to show those tracks that have not been purchased. And like we said, the left join brings all tables from the left and then matching records from the right. And then it gives you null for the rest. That is those places where you don't have records, or let me say where you don't have a match, you get null. Okay, someone raised their hand. Oh, okay. It was just a message. Okay, so quickly, let's just wrap up on this example and then we'll continue from where we stopped. So let me first run the track table. Okay, so I would want to get the track ID from, or let me just get the track ID from the track table and the invoice line also, so you can see the difference. So I'll say T dot maybe track ID, T dot track ID, and then I'll be using who is using I dot who is using the handle?
It's gift.
Okay, do you have something to say, gift?
We have invoice line on
You said I
database. I
can't hear
think
you.
it's invoice item.
Invoice ID. No. I'm intentionally using the track ID for both of them. So the one on the left to bring all
No,
of it.
no, I mean the invoice line. You selected all from invoice line.
Yes, that was intentional.
Yes,
I just wanted to see all the
but we only
information on
have
the invoice line table.
okay. We don't have a table called invoice line.
Oh, you don't have a table called invoice line?
No, we have a table called invoice items.
Okay,
Invoice
yours.
underscore items.
Okay, hey, that's what you use. That's what you use. Thank you for
Okay,
pointing that
okay.
out. Yes, that's what you will use. Let me see again.
All right.
Yes, I have invoice line. You have invoice items. Okay. So I'm bringing in the track ID from both of these tables. Okay, let me just put this here. Yours, yours might be invoice items. Yours might be invoice
Uh,
items.
there's invoice line ID on my own. I
You
have
said
invoice line. I have invoice line ID on my own.
that's a column in invoice line table. That is a column.
Yes.
Yes,
Okay.
that's a column, not a table. That's a column. Okay, so
So
you said
which one are we using?
eh, for me, I have the invoice line. If you have invoice items, you're using invoice items. So if you have invoice line table, you're using invoice line table.
I have
That
both. I have both invoice line and invoice line ID.
on the same. No. Please get what we are saying. I said invoice line and invoice items. This
Okay.
either you have this table or this one. They have the same
Okay.
information.
Okay.
Yes.
Okay. Yeah.
Okay. All right. All right. So where was I? Okay. So from the track table, we want to bring. What else do we want to bring? Probably the name of the track. Probably. Let me just say T name also. I think that'll be all. Okay. Then I'll say from first the track table, and then I want to use a left join. Remember everything from the track table now, and then left join, and I'm using the invoice line table, and then I'm using this instead. Now please take note of what I'm using. I'm intentionally using, or let me just stick with on, since you guys are more familiar with on. Let me just stick with that. Let me give alias T and alias I. Okay, then I'll say on T dot track ID, comma, oh sorry, equals I dot track ID. Okay. So let me just run this to see. Maybe I can bring in maybe let me bring in unit price from the invoice line table too. Unit price. Okay. So we want to see those tracks that have not been purchased. So let's just see how it goes. Okay. So we have okay. So observe this. This is the track. The first track ID we are saying is the track ID from the tracks table. Look at this. Is the track ID from the tracks table, and then the second track ID we are seeing is the track ID from the invoice table. Now I chose to display them immediately. I chose to display both of them so that you can see the difference. So look at this. On the tracks table, you have track ID 7, but on the invoice line table, you see you don't have the track. You don't have track ID 7 because it was not purchased. And then you can see the name of the track. Look at it. It's also from the track table, and see the unit price, which is from the invoice line table. You see it is null. You see it is null. And then we can further stretch this, or we can make this even better. We can say we want to return. In fact, we just for the second part, we just say we are getting rid of the track ID table, of the ID from the track table, and then we just want to say where I dot track ID equals null. That is, now this means where you have null now, where everything is empty for the track ID. That's basically what we want to see. So this is going to just represent those places that, those are tracks that have not been purchased. So if I run this, hold on, what's going on? Let's see, where I the track ID equals null. Hold on, let me remove this first. What is going on? Okay, all right. Okay, so what happened when I put the vehicles I the track ID equals null? Let me see. Could it be saying this as a text or what? Could this be the case? Hold on, I'm trying to see what's going on. Okay, that's not it. That is not it. So let's say I remove track ID instead. Let's see how it goes. Still the same issue. Okay. So what's going on? What's going on really? Let's see. We run this. Okay. Then what's going on? Why is it not showing only the null values instead? Because that's what we wanted to display. We want to see those tracks that have not been bought, those tracks that have not been purchased. We want to see them. Okay, let's say I bring in, instead of this track ID instead, let me bring in the one from the tracks table, and let me remove this. Hopefully this works. Hopefully this works. What's going on? What's going on? What's going on? Track ID equals null. Okay. Oh, okay. All right. So I think let me just put both of them. T dot track ID. Put a comma. I dot track ID. Okay. Okay. So this is strange. Why is it doing this? Why is this not being displayed? Let's see. Someone say something. Okay. Okay, no one is saying anything. Okay. All right. So I'm trying to just bring those rows where we just have null. I'm trying to. I don't know why it is doing this. I'm trying to get the track ID, the name, and the unit price, where the track ID is null, is totally empty. Let me see what could be wrong. Should I use this null instead? This will give an error. Oh, okay. Okay. All right. Okay, so I can get rid of the unit price now. There's no need for it. Okay, guys. So what we have here are basically those tracks. So let me say, I don't know. Let me just give it as track dot track ID. Let me just display it this way as track dot track ID, and this one would be as invoice line dot track. Okay. So it's just intentional. I just want to put enough information there. Okay. So this is the track ID from the track table, and this is the track ID from the invoice table. And what we're trying to do is to see those tracks that have not been purchased. Those tracks that have not been purchased. And if you look here, there are tons of tracks that have not been purchased. From what we can see, track ID 7, you can see it does not exist on the track on the invoice line table. You can see 11, 17, 18, 22. So these are tracks that have not been purchased. These are just the tracks that have not been purchased, and you can see every single one of them. You can see the names of the tracks. They've not been purchased. Let's quickly do an experiment to see how true this is. So if I do select star from, let me say, from the invoice line table, okay, gift, you can go on. You can speak or gift.
To find out why on the where close, you have to change it to is known. Yeah, making. I want to find out why the is.
We can't really hear you well,
The is
Mr.
known
Gift.
is a close.
Okay.
Can you hear me? Can you hear me?
Yeah, I can hear you now. I can hear you now.
Yeah, I want to find out why that is became a
Okay.
clause and not equal to.
Okay. So now what I believe happened is this. Now for different versions of SQL, like we've said before, you see slight variations in the way they execute their code or in the way they specify conditions. Now for SQL, now what I discovered, I was using the equal to originally, and later I decided to use is null. This is the reason. I said it's different variations, but if you have used different variations, you find out that okay, this might work for this one and this might not work for this one. So the reason why I used is null, or the reason why it is null, not even why I use it, the reason why they probably designed it that way is because when you are using equal to, you are checking for a value that has been imputed, like by default. Equal to, so let's say when you're using equal to 7, you know that 7 is a value that exists. It's something that was imputed there, but then is null is just something that is generated if something does not exist. Null is something that is generated if you can't find it there. So if you're using equal to, you are pointing to a value that was imputed and then is null. Do you get the point now?
Yes, sir.
Okay.
Thank you, sir.
Yeah, you're welcome. You're welcome. So this is how it is most times. You just have to test and see which one is which one is not. So from what we have, let's just quickly check where let's say track ID. Let's just check track ID is 7 equals 7. Let's just see if we'll find, because we're trying to see from the invoice line. It has been stated that track ID 7 was not purchased. So let's see. So you see it is empty. It is totally empty, which means on the invoice line table, track ID 7 was not recorded. And if you check for 11 also, track ID 11, let's see, it's not there also. So you can test as many of them as you want, but we've established already here, if you run this, you see it from the track ID table, you can see 7, 11, 17. So these are basically those guys that we don't have on the invoice line table. They are not there because they've not been purchased. So that's that on that. So we already looked at the cross join yesterday, and we already established that it just gives you a cross product. It just gives you every single possible combination. It does all it does, and you see that we are not even using any key. We are not joining on. We are not using on anything. We are just giving all possible combinations of the name and the title from both tables. That's what it does. Like I said yesterday, it is not really used for practical cases. It's not really used. It is mostly used just for testing actually, because there is no way on earth you will tell me to do a cross join. You are trying to extract any insight. If you think about it, it does not really make sense. If I'm trying to extract any insight and you tell me I should use the cross join, what do you want to see? This is probably the only thing you can do. Just match every maybe every column, every value in a specific column from one table to the values in another table. That's the best you can see. And that's why you can see 95,425 rows returned. 95,425 rows returned, which does not make sense if you think about it. No table or no combination that we've carried out so far, that is maybe the left join, the inner join, or even querying a single table has up to, do we even have up to 9,000, or let me know, let me not end down, but do we have up to 20,000 records? I doubt. If you check all of the tables, I don't think we have 20,000 records. The invoice table that might even be the largest. Let's see. Select count count star from invoice. Let's just see how many records. Oh, see, 412 records from the invoice table. So we have from doing the cross join, we have about 9,000 or so, 95,000. It makes no sense. If you do from the customer table, how many customer records do we have? If we have to look at it, we have just 59. If it's from the album table or artist table, we are trying to see 347. If you check for the artist, can you imagine? If you check for artists, how many artists do we have? 275. Imagine. So wow, combining both of them now led to about 95,000 records, which is something that will not be using in the real world. It's not something that will be using in the real world. But Lord knows that they just created it for testing, just for testing. That's why they said they created it. So for our last join, we'll be looking at the full outer join, or um, outer join, outer join. They mean the same thing. For some programming languages, you might have to specify full outer join, and for some, it's okay to specify either full outer join or outer join. It works either way. So let's see if we have, if we can work on any example for the full outer join. So what the full outer join does is it returns all records from both tables. All records from both tables. Let me quickly bring that out on display here. Okay, look at this. This will return all the rows from both tables where there is a match on the joining column. In other words, a full outer join is the same as taking the left and right joins of two tables simultaneously. This particular type of join is similar to the union set operator. We'll get to that. But what the full outer join does in reality is it just joins all of the records, whether they match or they don't match. It brings all values from both tables, both the ones that match and both the ones that don't match. Remember that the left join brings all of the records from the left table and then matching records from the right table, and then it will give you null for those ones that do not match. But then for the full outer join, it's bringing all of the records from the right, all of the records from the left, and it's just joining them whether they match or not. Whether they match or not, it does not really matter. Are we together? Are we following? Okay. So quickly, let's look at an example, just to display it. So let's say we want to see. Let me just put an example. Let's say show all customers and invoices. Now, even if they don't match, we just want to see every single thing from both tables. Okay, so let's quickly go through. So let's see, let me just use select star first. Select star, so it will select all of the columns from both tables. Select star from the customer table first, and then from customer, and I'll use full outer join. I'll use the full outer join, and then I'll say invoices, and what they have in common is the customer ID. So permit me to use this. It's just easy for me to use it. I prefer it. That's why. So you can go on to use on. same thing. So using the customer ID, this is what they have in common. So let me execute this and you'll see what we've been talking about. Okay, so there is an error. Okay, I used invoices instead of invoice. So let me re-execute and see what we have. Okay, so look at this. Just look at what we have. It says we have 412 rows returned. Okay, so look at this. Just look at what we have here. You get to see the out. Just look at it. It's just a combination of both tables. You can see all of the records from both tables. You can see the customer IDs repeating themselves. That's because you have the customer ID repeated on the invoice table. Um, so you can see all of the information here. Now this is I'll just say that this is not this type of join. You see, the most used type of joins that we come across that we really need is just the left join, the right join. Probably say that one is even needed. But I think we can use the left join and the inner join, and then the rest of our query. Those are the type. The left join and inner join. Those are the two most used. For the right join, like I established yesterday, is just the opposite of the left join. And then for the full outer join, just like we've seen today now, it's just a combination of both rows, whether they match or not. Okay, and just look at everything. Like it's not really the best. Maybe we should just let's just trim the information that we are saying. Let's not select all of the records. So let me say first name and let's say maybe total. Um, let me put last name also, last name, and then total from the invoice table. So let's see how this looks. Let's see how it appears. So you can see Louis. You can see Louis as many times as you want. You can see all of the information. Everything is here. You can see all of Lewis's purchases. You can see what he bought this time. You can see what he bought at different times. You can see how much he spent at different times, and you can see the same too for Leonie. You can see how much Leonie spent every time he or she came. Let's check something. Let me check the date. Let me see. Select. Um, Let me see if the invoice has date. Has the date column. Let's just check. Let's see if we have a date column. Okay, so we have date, invoice date. I think this is good information. So we can see the invoice date also. Invoice date, and you will notice that I'm not using aliases. And the reason why I'm not using aliases is because I know that the first name belongs to the customer table, the last name belongs to the customer table. We do not have overlapping column names here, share here. So that's why I can just use the column name directly without using the alias. And I know very well that total is on the invoice table. I know very well that the invoice date is also on the invoice table. So I am all right. So let's run this. Now you can see that on the, I think this is YMD. Yes, YMD. That is year, month, and day. So on the 10th of March, Lewis spent $3.98. On the 12th of June, you can see how much he spent. On the 14th of September, you can see how much he spent. So I think this is even good information. You can see for individuals, and you can go on to even explore. You can say maybe let me see where, let's see if we can use, I don't know Lewis's customer ID, but we can say maybe a particular customer ID. You can check for a particular customer ID. Let's say where customer ID equals 1. I think that is for Lewis. I think Lewis is customer ID 1. So if I run this, okay, so Lewis is customer ID 1. You can see all of Lewis's purchases based on this. Are we together? Hope you guys are following. Yes, you can see all of Lewis's purchases. So whether Lewis made it, you can see everything here, every single thing you can see here. And Yes, I think that is that. We already established before that every customer made purchases, so you won't get to see null. You won't get to see null. Everybody made a purchase, so you see everybody's information, and you can even decide to use Okay, DG, you have something to say. Please go on. Go on.
Mr. Gbemi, so your line 131.
Mm-hmm.
So I can see you wrote select first name, last
Mm-hmm.
name,
Yes.
quota. Now, when do you use such an expression and when do you use all?
Oh, okay. I think from the first class of SQL that we established that when you want to see all columns in a table, you use star. You use star, select all when you want to see all. But then when we did select all, we could not really make sense. In fact, let me put this out and let me just put select star. Let me just put this on the side first and then let me put select star so that you can see. Let's try to make sense of this information by selecting all of the columns. Now look at this. Look at this customer ID 1. Look at the repetition. Look at first name, last name. Yes. Look at the company. There's too much repetition, too much redundancy. You can't really make sense of it this way. Even though the information is correct and it can be made sense of in reality, but then you find out that it is too much, at least for the human eyes to just understand. It's too much information all at once. So we decided to just cut down the information we were looking at, and then we just decided to use specific columns from both tables. So we use first name from the customer table, last name from the customer table, total from the invoice, and the date at which the purchase was made. So you can see all of the days. So from 2008 to 2010 or 2011, you can tell that Louis made purchases from the music store. Hope that explains why we use star and why we use the specifics. Okay. All right. So that is that. So that's that on full outer join. Let's see if we can come up with another example. I think we already did this. Let's just say we already did this with one of the joints, but let's just do it again with full outer join. So we want to see the total sales per customer. Like this one was, I think it was the one that was making Tosin glitch. I don't know if Tosin is still here. Tosin, are you here? Is Tosin here? Is Tosin in class? Let me check. Tosin is not in class. Wow. Okay, but this was the question that was making um Tosin glitch. If you check, or let's just see amount spent by customer each time. I think even this question too is similar. If it's not even the same thing, it's the same thing actually. It's the same thing. It's just the choice of words that is different. It's just the choice of words that is different. So I think we are done with outer join. I think we are done with it. So what it does is it just combines all of the records, all records from both tables. That is your table on the left, your table on the right. Even though they are not of the same length, it will just combine them. Full outer join, it will just combine them. And those places where the records, let me say maybe the table on the left is longer than the table on the right, it will just give you null, 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 and null. That's all it will do. So that is that on full outer join. Please and please, you have to do some research so that these concepts can be further established and solidified in your minds. Like I always say, it is not enough to just watch the recordings, to treat examples in class. You might think you've gotten it now, and it might be true for some of you, but then by the time you say, okay, let's sit down and practice, you find out that there is something you still do not understand about it. So please do not stop here. Research. There is a vast resource online. There are vast resources online. So please do well to make research, and you'll be fine. Okay, so that is that on joins. Now here we have I think we also have union. So we'll be treating union under set theory. Let's see, union, let me see. Okay, there is no explanation here for the union. Okay, let me use the explanation here, and I will explain intercept and except. So now we are dealing with set theory already. In fact, let me start here. There is no explanation about set theory. Okay. So we all did mathematics at some point in our lives in secondary school, um, and I am assuming, I hope it is a correct assumption or a healthy assumption, that everyone came across set at least once. At least once. I don't know if that is true for everyone. Did we come across sets rather sets? Did we come across set, like for most of us? Did we? If you did not come across set, you can give a thumbs up. And God is seeing everybody. If you lie. So did we all come across sets? Okay, Latif came across set, Dorcas came across set, Gift, okay, DJ Benny, okay. Thank God you guys are being honest. Okay, Sonia is not saying anything. Okay, Adedeji joined. Okay, yes, Adedeji was the okay, it's for next cohort, so he just joined yesterday. Okay, he's joining today also. Okay, all right. Okay, Sonia has decided to respond. She has given us thumbs up. Okay, so I'll still ask Sonia questions today, and hopefully I won't see Sonia left the meeting. Okay, so yes, in dealing with sets, there is something called set theory. And when we talk about set theory, I don't know how I will even show you guys this thing. Okay, let's start with union. Does anybody know what union of sets mean? Union of sets. Does anybody know what union of sets mean? Anybody? Don't worry, it is okay for you to get it wrong. The only sad news will be after that, after we've covered it, we've explained it, then you still do not get it, and that will be the sad news. So it is still okay if you have forgotten at least now. And some of you might have hated mathematics. So who wants to try for us? Who wants to try? Who wants to bail us out? If nobody volunteers, I'll still call names. So anybody. Okay, let me pick someone. Dorcas was not in yesterday's class, but I don't want to call her yet. I want to call her for greater things. Let me see. So let me see. Okay, Sonia, would you like to help us? In fact, I'm not even asking again. Just help us out, please. Help us out, Sonia.
Good afternoon.
Good afternoon. Good afternoon.
The union of sets should be the joining, like combining of two or more sets with common elements that are in each of them.
Oh, okay, hold on. You said common elements in both of them.
Yes.
Is that a criteria, or we can just join them together whether or not they have the same elements?
No, they must have something that's joining all of them together, I think. Okay. I've not gone through that material.
It's not even, if you check, okay, I think it's there. Okay, let's look at it. So if you look at the union of sets, look at this. The union operator is useful when we need to join tables of query results, tables along vertical axis. When we want to combine or stack rows from two tables. Now there are rules guiding it. If you look at the context of programming now in the context of mathematics, I don't know, Mr. Namdi is the guy of mathematics. That man would die. In mathematics, when you're talking about union of sets, you are basically just joining two sets together. It does not matter if they have the same values or not. You are just joining them together. Now, when it comes to programming, when it comes to SQL, now when you're dealing with set theory in SQL, for the union, there are rules that guide it. And one of the things that, whenever you're using union, one of the things that you must have is that Okay, so the number of columns in both tables needs to be equal. The number of columns in both tables need to be equal. That is, you cannot be joining, you cannot perform the union, you can't use the union operator when you have one query that returns just 3 columns and another query that returns 2 columns. That is what this means. And the second rule says that the columns that we want to combine need to have compatible data types. Compatible data types. So this means that we are combining, whenever you are combining two tables, those columns that you are combining, that is, we are combining, let's say, name from the first table, and then name, let's say, name from another table, they must be of the same data type. They can't be different. So one of the rules states that we can only apply the order by clause, order by, to the combined unionized. That is, you can only use the order by to, let's say, when you've joined them together, that's when you can use the order by. You can't use the order by on half of the query, and then you can't use order by on the second half of the query. And hopefully I'll show us what we mean by these things. So the next one, we have the group by. Okay, so the group by clause can only be applied to individual tables. That is, before you use the union operator, you use group by on the first query, and then use the group by on the second query, not the combined result. Not after unionizing the whole thing, then you try to use group by, you have an error. And we also have information here that says that it will not permit any duplicate rows between the two tables. That is, there will be no repetition. There will be no repetition. So here we have, it says here that, however, we can include these duplicate rows by adding the all keyword to the union. So there is union and there is union all. So union will not allow duplicates from both tables. It will not allow duplicate records. But then for union all will allow duplicates. Do we understand? Do we understand the explanations? So let's look at union a bit. Let's look at union. Let me say set theory. Let me put it here. Set theory. Okay. Now, like I always say, I don't expect you to just swallow everything, digest it immediately. Sometimes you have to repeat and repeat and repeat. So for the union, let's see. We'll be using examples as usual to treat these concepts. We don't just want to talk about them. We want to look at examples. So let's say, let's get all customers. I don't know. Let me see. Let's see. Okay. Let's get. Let me see. Example one. Now, before I even, okay, let me just run this example one. Let me say, get all customer and employee information. Now, if you look at this, look at what I said, get all customer and employee information. Now, if I run select star from customer and I execute this, this returns all information from the customer table. This returns all of the information. And if I come down here, please take notes. Look at what I'm doing. I'm talking about, look at the question, get all customer and employee information. Look at it closely. And then if I use employee this time around from employee, now look at the columns we have in the customer table. First, we have the customer ID, we have the first name, we have the last name, the company, the address, the city. Now, if I run select star from employee, look at what I have instead. Employee ID, last name, first name, title, reports to. Now, if I use the union, observe now, this question already is faulty because it is against the rules. The tables are already like they have information that are against the rules of using the union operator. So let me just use union. So this is how you use your union. You write your first query and then you write your second query and you can put your semicolon, and then if we run the two, we expect an error. And look at this. execution finished with errors. It says results select to the left and right of union do not have the same. Look at this. They do not have the same number of result columns. They do not have the same number of result columns. That is why it is giving the error. So even the number of columns on the customer table is not consistent with the number of columns in the employee table. So whenever you are using your union, you want to make sure that whatever information you are getting from the first table is consistent. The number of columns you are getting from the first table is consistent with the number of columns from the second table, and then their data types must also correspond. Are we together? Okay, so let's improve on this. Let's say I am getting first name now, first name comma last name from the customer table. Now if you check this alone, if you run this alone, just observe, you see here we have the first name and the last name right here from the customer table, all 59 of them. And we can check for first name and last name also on the employee table, from the employee table. So when I run this in isolation also, look at what we have. We have the information of the employees, all 8 of them. So there are just 8 employees. So if we decide to use the union now, what do you think will happen? Anybody? Does anybody want to try? What do you think will happen? Will we have an error message again, or it will perfectly combine them? Is there anybody?
I think it's still okay. Sorry,
Oh
I
yeah,
think
go
it will
on.
perfectly combine them because the number of columns are the same, even though the number of rows are not the same.
Okay, beautiful, beautiful. That's a very, 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 very good explanation, because you said even though the number of rows are not the same, what it is combining has to do with the columns. Sure, you get. It is just joining the columns. That's what it is really focusing on. Thank you for mentioning that. Now, we said that the data type should also be the same thing. Before I run this, let's quickly check. If you check the database structure, if we quickly check for, let me see, the employee table. Now you can see last name, first name. You can see the data type n varchar, variable character 20. N varchar is what really matters. So if we check for customer, if you check the first name and the last name also, you see n varchar also. Like I said, it's the data types that matter. It does not matter the variable inside, the number inside of it. What really matters is that they are both variable characters. So the data types are consistent. So if I execute this now, remember we saw that we have 59 customers, and then we have 8 employees. So if I execute this, we should have about that should be about, is it 70, 76 now? I'll be 67 rather, 67, not 76, 67 rows returned. So it is a combination of both employees. You can't even see the difference. We can't even see the difference. I don't know if you guys are following. We can't even see the difference between them. Both have been merged. They've been combined. So we can't even really know. Are we together? And like I said, you can use the union all. Even with this, we can't even know if we have duplicates. We can't even know for sure, because 59 plus 8 is 67. Truly, if we had duplicates, the union would have removed those duplicates. So let's use all. I think we'll still have 67, because like I said, we do not have duplicates. But let's see. Look at this. Still 67. Still 67. Remember, the union all permits duplicates, while union does not permit duplicates. So if we have the same result after using union, and then we have the same result after using union all, it means that we do not have duplicate records. We do not have duplicate values. Are we together, guys? Are we together? Are we together? Okay, so that is that on union. So I'm going to be dictating now. Someone is going to share his or her screen. Okay, so who wants to volunteer? Who is with his or her laptop? Who has their laptop with them? Gift, do you have yours? Dorcas, do you have yours? Yetunde, Latif, Chidima. Okay, Dorcas has her laptop. Any other person? Okay, let's not waste time. Okay, DG has his. Okay. I'm thinking to myself, okay, DG, yes, you should share your screen today. Dorcas Stone will still come. Who else? Gift to share. Now go share, everybody go share. Let's just DG, so you'll be sharing your screen. So let me stop sharing so that you can share. So hope you are ready to share. Hello. Okay, let Dorcas.
I said yes.
Oh, okay, I didn't hear you. Okay, so you can share your screen. I'm going to stop sharing now. I'm going to stop presenting. So the floor is yours. The floor is yours. And time is really, really moving fast. Can't even understand what is going on. Okay. All right, so can you like zoom in so that everyone can see clearly, or maybe I should just use my full screen too. Let me use full screen. So when you guys are watching, okay, so what we want to do is we want to see the customers. We want to merge customers, the city from the customers table, and also billing city from the invoices table. We want to merge them. So let me just explain this again. So the only thing we want to select from the customer table is the city, and the only thing we want to select also from the invoice table is the billing city. So it's like we want to see the city from both customers and the billing city, so from the invoice table rather. So select city, okay, from okay. Remember, we are still dealing with union. Okay, very good. Selecting this first. Okay. Okay.
Then what's up?
Yes, we are using the union. We are trying to merge.
Okay.
Yes, we are merging the two columns. So we are using the union, and then we are selecting the billing city from invoices. The billing city from invoices. Billing city. Now, before you run this, you can keep writing your query from the invoices. So we have 59 rows as usual from our customers. We have 59 rows. Okay. So let's see for no, just run select billing city from invoices alone. Run that first. Let us see how many rows we will have. Okay, 19. Okay, 412. Okay, so you can run everything at once now. Run everything at once. So what do we have? 53.
53 rows.
53 rows. Now, this means that there are 53 rows. 53 rows that have. It says exactly. It removes the duplicates. Exactly. It removes the duplicates. It got rid of the duplicates. So we had many duplicates. So invoice had 412 cities. Probably many of them were duplicated. You know, it's possible for 5 customers to be from the same city, and it's even possible. It's not even like it's possible. That's what happened. We have multiple records of the same customer. So we had about 412 records in the invoices. So definitely the customer's city, the billing city was repeated. It was repeated. So that makes absolute sense. So when we used the union, you see it cut everything down to 53. And like I said, we had 59 from the customers and then 412 from the billing city. So when we combine them, everything gave us 53. And then in reality, 412 plus 59 should be about 471, if I'm not mistaken. It should be about 471. So This means that if we use union all now, we should have more than 53. Let's see how it goes if we are not mistaken. So you can execute, let's see. Okay, look at this. So look
Yeah,
at how many rows were
471.
returned. 471 exactly.
471.
Exactly. So hope we all are following, please. Hope we are following. It's important that everyone is on the same page. So this is just a way of saying, okay, count the total unique. This is just the same thing as saying count the total unique cities from both the customers and the billing city. You just want to know how many cities were recorded in all of your database. At least, let me just say for the city and the billing city, you can go ahead and you can do union for the employee too. You know, employee, I think employee has city too. I'm not sure, but they should have a city column. Quickly run select staff from employee. Let's see. Or okay, you can do this also. This works too.
Okay.
Yeah, that works too. So you can go to yes. So employees. So did they have city? We have address. Scroll to the right. Let's see.
Yes, they have
We have
city.
okay. So we have city. They have city also. So let's go
Yeah,
back to execute SQL and see. Let's see. So you can just do union select city from employee. Let's see.
okay, union, right?
Yes, you can use union also. Let's see how that works. Select city from employees. City from employees. Okay. Okay, so you can execute everything at once.
Everything.
Yes, just everything. Let's see everything. So using the union alone, let's see. 55. Look at this.
55.
So that means there are 2 extra cities. So we have 2 cities in the employees table that we cannot find in either the billing
Yeah.
city or the
Okay.
city from which the customers are from.
Yes.
We have 2 extra. Do you guys understand? Do you understand what the union is doing? It's important that you are getting this. I don't want to assume anything because assumption can be costly when you are dealing with data and even when you are teaching. It's very, very costly. So let's not assume. So DG, thank you very much for sharing your screen. Well done. So let me just celebrate you small. So you can stop sharing and I'll share my screen. Okay. So I'll be sharing my screen once again. Okay. Can we all see my screen? Okay. So Ogweni has done a wonderful job of sharing his screen and helping us to see the union and the union all also. Okay, so moving on. Yes, let's go to our classroom and see where we are at. So set theory. So we've looked at the union. We've already established what it does. Now we have intersect. Intersect. Now, according to mathematics, intersect only returns those things that 2 sets have in common. It only returns those things that 2 sets have in common. Do we agree? Do we all agree with that? Intersection. Guys, are you with me? Are you with me? Okay. So the intersect returns those things that both sets have in common. Now let's see quickly. Let's see the rules guiding intersect. If we have, okay, there are no rules here. Okay. So what the intersect does, while the union focuses on columns, like I said, the union focuses on columns. The intersect focuses on rows. It returns only the rows only common rows between the two queries or the two tables. Between your two queries, actually, it's not just about your two tables, it's about the two queries. Now let's go through this. So follow me closely. The intersect might be more complex compared to the union. So let's see. Let me see. Let's say we want to get cities. I think union and intersect might even be, although union just focuses on the columns. Let's see intersect. Let me do select first. Let me just see distinct city. Okay, let me see from the customer table first. Let me just see how many distinct cities do we have from the customer table. Okay, 53 distinct. 53 distinct customers. 53 distinct customers from the customer table. Okay, and let me see, maybe select distinct now. Billing city from the invoice table. So I'm putting table. I got carried away. So let's see. Okay, so there are 53. Wow. Okay, 53 from billing city, 53 from customer. Oh, yes, 53 unique cities from the customer table and 53 unique cities from the invoice table also. Okay, so remember, intersect will only return cities that are common. It will only return cities that are common. It will only return, I said, I've already repeated it. It will only return. It will only return cities that are common. That is all it will return. Let me remove this. So let's see how this goes. So 53. Now it is only returning 53. Now this means that all 53 tables that you find in the customer table, all 53 cities that you find in the customer table, you can find in the invoice table. Are you guys following? All 53 cities that you find in the customer table, you can find in the invoice table also. That is why even after running them in isolation, you have 53. This one you also have 53, but then by the time you do the intersect of both of them, it will also return 53 because you can find Stuttgart in billing city. You can also find it in the customer city. Look at it, Stuttgart also, or Stuttgart. You can find it also. Oslo from the customer table, you can also find Oslo right here in the billing city. So that's why when we run the intersect, what do they have in common? You find out that all 53. So you can see Stuttgart, you can see where is Oslo now? You can see Oslo too, you can see Ottawa, you can see every one of them. So the intersect will only return rows where you have the same city or the same, where there is a match, basically. Where there is a match. That's what the intersect does. Where they have things in common, those are the rows it will return. Are you with me?
Mr. Gbemi, so that means it will just bring out it will not combine them, it will just eliminate the duplicate and make it one. Is that what you're saying, sir?
Exactly, it's just an intersect, not even duplicates, no. It's doing, let's say you have, let me create a scenario in my head. Okay, let's say you have a set 1, 2, 3, 4, 5. Are you with me?
Yes, sir.
Okay, that is set A, 1, 2, 3, 4, 5. And then you have set B, 4, 5, 6, 7. If we use the intersect on those two sets, that is set A, 1, 2, 3, 4, 5, and set B, 4, 5, 6, 7. The intersect of those sets will produce another set, and that set will only contain 4 and 5. because we have 4 and 5 in set A, and we also have 4 and 5 in set B, or maybe 3, 4, 5 in set A and 3, 4, 5 in set B. Do you get my point?
Yes.
So it only picks those things that are common in both sets. Do you understand?
Yes, I do.
So only those things that are common in the billing city from the customer table, and then the city from the customer table rather, and the billing city from the invoice table. So those are the only things that it will return. And let's see if what other columns do they have in common. Maybe they have the customer ID in common. Let me say customer. Let me just do customer ID. Let's make it rich. Let's make it rich a bit, although it might bite us back, might give us error, but let's see. We should not be afraid to make mistakes. Please take note of that. Don't be afraid to test something. Okay, like I said, we have errors, and I think it's because we used this before the distinct. Yes, whenever you're using distinct, you're likely going to use just, or let me just see customer ID again. Let me see. Let me remove this, and let me see if it's because we are using. Okay, so usually whenever we use distinct, it's always on its own or with an aggregate. But then, okay, look at this. So it's because we used this before. We used this before, so the distinct should come first. And now look at this. The customer ID 48 is still the same thing. Okay, look at this. Something interesting is here. We have 59. 59. 59. Hold on, let me see. 59 records. I'm trying to see if we have any duplicates. Look at this. Guys, observe. Guys, can you see this? So because we introduced customer ID, you see it now? Two customers from Sao Paulo. Do you see two customers from Sao Paulo? That's why it's doing this. Let me see if I can use distinct again on this. Let's see what happens. It's good to experiment. I hope that time is still on our side. Let me see distinct. Although this one will likely throw an error exactly. We are using distinct twice, especially. Okay, so we can't use it twice in the same query. But do you guys get my point? Do you guys get the point? You guys get the point of using this. Okay, so look at this. Berlin also. Berlin. Two different customers from Berlin. So look at this. Just give us those things that are common, and if you get rid of the customer ID once again, if you get rid of the customer IDs, if you run this one alone, you can see we are back to 53. So these are the things that it has in common. Just these three, the distinct city, the distinct billing city, 53 on their own. When combined, they will still give you 53. Okay, so that's one question on INTERSECT. Let's quickly see another question on INTERSECT. Now, this one might be quite challenging. So another example on the INTERSECT. So let me say maybe example 2. Is it example 2? Let's see. Okay. So let's say let's try to get artists. Now this one might be tricky, like I said. We want to get artists who have rock and metal rock and metal albums, rock and metal albums. So we are going to use INTERSECT. And what we are really looking for, in fact, let me just write a query first to display just the names of those people that have rock albums first. Just follow me closely. It's a chain of thoughts, so follow closely. So I'm saying select star, then I'll say from album first. Album. I want to see album. Okay, so the album is here. Okay, we have information. Okay, but then we don't have album ID. Okay, the artist ID. We are trying to see rock and metal. Rock and metal. Where do we have that information? I'm trying to see the genre. Okay, I think it's the genre table. So let's see genre to see if we will have those if we have information about rock or whatever. So let's see. Okay, we have metal and then we have rock. Okay, so this is the table that will help us to say that will help us to get information on rock and metal. So let's keep that here. And now we want to get the names of the artists. So if we do select star, from artists, okay, select star from artist. Now observe the genre table. The genre table only has the genre ID and the name of that genre. So if you run artist, you find out that the artist only has the artist ID and the artist name. There is nothing that links these two with each other. There is absolutely nothing. I don't know if you guys get my point. There is nothing that links these two together. Then what we should be looking for now is a table that we can use as a link between these two. That's what we should be looking for now. We should be looking for a table that will serve as a link between the genre table and the artist table, because we only have artist ID and then we have genre ID on the genre table. You don't have any column that links them. So if I say select star, I'm thinking of album. I think album should have the genre ID and the artist ID. Let's see. If I run this now, even artist ID only has the album ID. Interesting. Interesting. Wow. So how do we get this? What do we use then? I'm trying to see. Let me check track. So this is how it is, oh guys. You just keep checking and checking, checking and checking until you find something that has what you are looking for. So select star from track. Let's see, we are looking for something that can link these two. Okay, so track has the genre ID. Does it have the artist ID? It does not have the artist ID, but then it has the genre ID, it has the album ID. So we might be using four tables actually. We might be using four tables, but let's see how this goes. So I'll start with the artist table. We know that we have name, so I'll say select maybe AR dot name from the artist table, and then okay, let me just select that alone from the artist table for now. And let me see from, let me say artists and artists, then I'm joining. I'll say join. I'm using the inner join. Remember that we are done with join now. We are dealing with set theory. So I'm saying join the album table, because the album has, let me see, does album have it? It's important that we check. Does album have the artist ID? Okay, it does. Okay, so it's safe. Join album, then I'll say using the artist artist ID. Artist ID. I forgot my alias. Let me just use AL for now, and let me use AR here. So let me just run this and see first. Let me see what we have. Okay, 347 rules. Okay, let me get the album. Let me see the names of the album first. Okay, title. So AL dot title. Okay. Okay, so these are the albums and the titles. Um, But then we do not have the type yet. We want to see what type of album this is. We want to see this album now that we have here. What type is it? Are you guys getting my point? I don't know if you guys are following. Okay. I want to see, I just want to see um, the type of album this is. And like we said, okay, what links the album? We have the artist, we have the album table now. If we are to go by, we can short track this by just using the inner join again, and we can just say inner join um the track table. Yes, the track table has the genre ID. I think, is that the case? I think it has the genre ID, and I think it has something that can link it with either of these two. So let me check. I'm running this guy again. Track table, so it has album ID. Okay, so I can just say using album ID again, using the album ID. Okay, so I'm joining them, but what do I want to select now? So I'll say genre ID, genre ID. So I'm just doing this to show you something. So let's say I'm calling this T, the alias T, so I'll say T dot genre ID. So we have the name of the artist, we have the title of the album, and then we have the genre ID, the ID of the album. So let me run this first. Now that I have run this, guys, can you see, do you understand this? Like you're just saying genre ID. We can't see the name of the genre. Abi now, we can't really see the name of the genre. So, and now this is where this thing can get really complicated. We have to join and join and join. We can either say we should check the genre table here, and then we'll just see, okay, rock is ID1, right? Rock is ID1, and then I can just say where let me say genre ID. Let me use t dot genre ID equals 1. I can run it this way, and remember that 1 is rock, right? 1, I can just do 1 is rock, and then I can run this, and we just have information about people that, okay, rock, and something you should note here is we have, I think we have duplicates right here. If you notice, we have duplicates, restless and wild 1, restless and wild, accept. We have too many duplicates. So let me see if there is a way to use if I can use the distinct. Let's see if I do distinct, let's see if it will affect it in any way. Okay, so now you can see, guys, are you seeing this, please? Are you seeing the effect of distinct? Did you see what we had without distinct and what we now have with distinct? So look at distinct. You can see only restless and wild appearing once now. Okay, this makes more sense. But then the only problem that we have now is that we are still seeing 1 instead of rock. So instead of staying like this, one thing we can do is we can copy this. I'm just intentionally breaking this down. I can just go straight to the point, but I have to break it down for you guys. So like we checked before, the genre table has the name of the genre, right? The genre table is the only one that has the name of the genre. So we can go on to say we will join again. We'll use inner join again. Use the inner join again, and then we'll bring in the genre table this time around. So we'll say genre G, and then we are using the genre ID because that is what the tracks table has. The tracks table has the ability, it has that column, so it has the ability. So all of this can be treated as a table on their own, and then we are joining with the genre table. So we'll say genre ID. Okay, so instead of t.genre ID now, I can bring let me say the name of the genre. Let me see if I run this in isolation. Let me see. I want to see the column. This one not too much. Let's see. Okay, genre alone. Let's see genre alone. Okay, name. All right, so I can say t.name, 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 and I can use where t.name or g.name rather, it should be g or not t. I beg. Hey, hold on with this. Okay, I'm using the wrong this thing. It should be here. G.name instead. Ah, g.name. Okay, and then we should have g.name equals, we can now say rock. Let's check this. Rock. Let's see. G.name equals rock. Okay. Let me quickly correct the one I have above. This should be, let me see. Okay, this should be t. It should still be t dot general id. So when we executed this alone, we had 117 rows, so it should not change for this one too, only that we'll have better information here now. But let's see, 117, and yes, we have 117. So now you can see rock, 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 rock. We have rock all through, rock all through. So like we said, we want to see a combination of two sets. We want to see those things in common. So we want to see an intersect of people with rock and what's it called now, metal. So I'll just copy all of this, and this time around I'm going to change this to metal. So I'll remove this and I'll put metal instead. Metal. So let me run this and let's see. Okay, so we have the name, we have, okay, so we can see metal all through, just 35. Okay, so we are going to use the intersect now. We are going to use the intersect, and let's see what we have. So we have 35 here, 117, 35 for metal, and 117 for rock. Please, I hope we are still following. Oh, I hope nobody has disappeared. Okay, Dorcas is still following. Who else is still following? Latif, Deji is following. Okay, wonderful. Okay, so intersect now. We want to see this information that is common. Now we are likely to get something we are likely to get empty rows. But let's see. We have the distinct name, we have the same column names, we have the title, we have the name, but then the values might differ. But let's see. It's an experiment. It's good to always try things out. So I'm running them, an intersect of all three columns, and boom. Okay, it returns some. Okay, but then it says syntax error. What's the syntax error now? Okay, yes, I ended the query here already. Okay, so let me get rid of that. That's why it's saying there's an error near intersect, because it's imagined that we ended this query, and that's why it even gave us a result, because it was just running the first query above just for rock alone. That was what it ran. So I've gotten rid of the semicolon now, and let's see what happens now. Okay, now see what I said, 0 rows returned. Who knows why we have 0 rows returned? Who knows why? Who knows why? Who wants to try? Because look at what we did. You know what the intersect does is it returns those things that are common. Those things that are common. So if you look at the tables that we have from the rock table, you'll find out that the values are different. I don't know if you guys noticed. Because one of the columns, at least for the first query that we ran, let me see. This zooming in is giving me. Okay, so if you run this one, let me run this one again in isolation. Look at this. All of this is rock. The names might be the same now. You know, it's possible to have one person that has both a rock album and yes, both a rock album and a metal album. But then if you look at what we did here, the intersect is supposed to return those rows that have like the same values. Those rows that have the same values. So if you check for this now, rock, by the time you run the next one, you have metal instead. So they are not the same thing. That's why we are having empty row. I don't know if you guys understand. That's why we have 0 rows returned. We are not grouping by. Okay, people have been sending messages. Can we add this table as? No, we can't. Okay, Latif says, can we? 57 minutes ago. Can we add this as a table to our database structure? I'm using the phone. No, we can't add it to our structure. Exactly. Chidima gets the point. Thank you. So metals and rock do not intersect. They don't have the same values. But if I remove these extra columns now, if I remove this and I just leave the name alone, just the name now, and I go down here and I remove the name also, see what happens now. I'm not sure we'll get empty rows anymore, because it's possible for one person to appear in to have rock albums and also to have metal albums. So let's run this again and see. Now look at this, guys. Observe. I don't know if you guys understand though, but Chidima seems to understand. Do we understand what is happening? Do we understand what is happening? Okay, Latif does not understand. All right, so let me go through it again. So the way intersect works. Okay, who else understands? Oh? I saw someone's thumbs up like when the thing was vanishing. Okay, DG understands. Beautiful. So the way intersect works is if you have, the way we use three columns now. 3 columns. Let me do this again. Let me add them again. Okay. So look at this now. This is for rock, Abby. That if you can unmute, let's interact in real time so that we can get this over with. So look at this. We have rock, right? Rock is here. ACDC is here. For those about to rock, we salute you. This is the title. So intersect now. The way to work is intersect expects that. Do you have 2 devices connected?
No.
Okay, why is there a feedback? Okay, so just follow me closely. So look at this. We have ACDC, we have for those about to rock, we salute you, we have the rock. Now, what intersect what it expects from the second table is that we also have ACDC, for those about to rock, we salute you, and then rock. For it to return an output, it must see exactly this. I don't know if you get my point. It must see exactly this, and because for the metal now, for metal, when we did for metal, all of the values are metal, so there is no way for it to find rock anymore. I don't know if you get my point. So for the first table we have rock, but for the second table we have metal. So already, because the 3 values for the rows do not intersect, they are not the same, it is going to skip them. That's why we have 0 rows returned. I don't know if you get now.
Yeah, I get that.
Okay, so if I remove the title now and the name instead for the rock, and then for the for metal also, so I just leave the name columns, just the name column. So if I run this now, I have just these names, right? Just these names here. And then if I run metal alone also in isolation, you see that I have just these names now. So what will happen is the intersect will now go and check for where there is a corresponding name in the metal, like for metals, and then where there's a corresponding name for rock.
Okay.
Do you get the points now?
Okay, so you reduce the column to just one.
Exactly, so that it can match.
Okay.
Yes,
that was what I missed.
Exactly, that's the point. Yes, so I'm glad that you get that now. So I'm going to execute them at once again. Let me see. Okay, so this is a lot of code, especially because I have zoomed out. Okay, so you can see. So these are the only people that have albums, rock albums and metal albums, basically. That's what the intersect helps us to do. Okay, so next, let me see. I think we're done with intersect. I think the last thing is the except. Okay, there is no explanation here also. Okay, so except is also one of those let me say keywords or operators. Operators is better under the set theory. And what except does is to give you those things that you have in one set but you do not have in another set. So it's like those elements that exist in set A and does not exist in set B. So let me give an example quickly. So let's say I have 1 2 3 4 and 5. This is set A now. Let me even do this. We are doing mathematics now. So A is equal to this, and then I have set B equals, okay, sorry. I have set B equals this. Then I say maybe 2, 4, and maybe 5. Now, when we use the except, the result will be those things that we have in A but do not have in B. So guys, what are those things we have here that we do not have here? What are those things?
1 and 3.
1 and 3, exactly. So the result will just be 1 and 3. That is what except does. That is what except does. So let's quickly look at an example. Let me just, I think I can use a multi-line comment here. Let me see, multi-line comment. I hope it is correct. Oh, it is. Okay, so they are using the same syntax for multi-line comments. Beautiful. So this is how you use multi-line comments. You use backslash star and then star backslash for the closing, to close the comment. So yes, let's quickly see an example. We can also, you see, the way these things work, the same way we've been using join, left join, we can use except. The way we've been using inner join, we can use I think we can use intersect if I'm not wrong. We can also so these things you can use them simultaneously. You can use not simultaneously actually, interchangeably. You can use them interchangeably. So let's see. I'm trying to see an example. Except. So again, let's look at track. Yes, let's look at that track example. Let's say tracks. Let me see. I hope this is correct. Tracks. Let me just see. Okay. So let me say tracks. Tracks that have not been sold. Tracks that have not been sold. So let's quickly see. We are trying to say except. Okay. So this is basically those guys that exist, or those tracks that are in the tracks table, and we are just comparing those that exist in the tracks table and those that do not exist in the what's it called now? The invoice table. So let me start. Let me just say select. Just to select. Let me say start from tracks first. I'm trying to quickly conclude this and see. Okay, select start from track. I have track instead. Select start from track. Okay, so I have track ID. I have the track name, and if I use select star from my invoice, I think my invoice will do me justice. The invoice does not have the track ID. Invoice does not have track ID. Okay, invoice line does. Invoice line does. Let me see. Okay, so the invoice has the track ID. Okay, the invoice line has the track ID. Okay, so I can just do select. Let me say the only issue is that the column names must be the same thing. So I'll just do select star. No, not star. Select track. Let me just say track ID from the track table. From the track table, and I'll do except, and then I'll say select track ID also. Track ID from the invoice line table. Okay, so when I run this now, I expect those guys that are present here but not present here to appear. Do you guys understand? Those guys that are present in the track ID but are not that are present in the track table, the track IDs that are present in the track table but are not in the invoice line. So we can easily just do this. Now look at this. Observe, guys. Remember that when I was giving that example of the left join when we started, you know, I just gave that quick example to show, in fact, let me look for it. There was an example we looked at just to quickly, let me see, last example I remember. Where art thou, oh example? Okay, this is it, yes. So look at the result. Now observe this. 1519 rows. You can see 7, 11, 17, 18, 22, just like this. I don't know if someone can help us to just maybe take a screenshot of this and we'll use it to compare the values that we have. So look at this. You know, the question here said show those tracks that have not been purchased. When we use that left join example, when we just quickly went through it, so this was what we did, those tracks that have not been purchased. So we ran this and we're able to see, look at this, 7, 11, 17, 18, 22, 23, 27, 29. You see, same thing, 1519 rows. I don't know if you guys understand. It is literally the same thing, only that using the left join gives us more information. And when using the except, you know, whenever you're using these operators, when you're dealing with set theory, you must have the same number of in fact, if I try to do, maybe let's see, if I try name, let's see what happens. In fact, I think we can use name also. Let's use name. Let's do name, since both of them, oh, this does not have name. The invoice line does not have name, so we have to eliminate name. Let's see what happens if we use 2 columns here, 1 column here, although it should be the same number. So there's an error, you see it. Selects to the left and right of except do not have the same, look at this, they do not have the same number of result columns. So the only difference between using the except here now and the left join that we just checked again is that this one just returns those tracks, while the left join returns both the tracks and the names of those tracks. It gives us more information compared to the except. Are you guys following? All right, so depending on what you want to see, Sha, you can use whichever you desire or whichever one you choose. Let's see, I don't know if there's any other example that I can use. I don't know, honestly. But do you guys get the point of except? Do you guys get the point? So it's basically things that are present in one that are not present in the other. Intersect is those things that are present in both of them, in A and B. Union is just a combination of both while eliminating duplicates. So quickly, let me just give an example of let me see, union. I just want to see if we can put union to the, okay, so union is something like this. You have set A equals, let me say 1, 2, 3, 4, 5, 6, and then for B you have maybe you have 6, 5, let me say 6, 5, and then you have maybe 2 again, and then you have maybe 4, and then you have 8, and then you have 10. So when you apply union on this will be the result. When you apply union on this, you have a set, it will be 1, 2, 3, 4, 5, then you have 6, and then you have 8, and then you have 10. So this is what union is. So look at this, it's taking everything from here and everything from here, but it is just eliminating the duplicates. So you can see 2 here, you can see 2 here, so it just throws away one of them. You can see 4, you can see 4, it throws away one of them. You can see what else can you see again? Okay, 5 is only here, so it puts the 5, it puts this 5, 6 is here, 6 is here, it just picks one of them. And then you see 8 is only common here, 8 is only present here, 10 is only present here. You don't have it here, but you see it puts both of them there. So that's what union does. It's a combination of both of them. But then union all will include the duplicates. So it will include an extra 2, an extra 4, an extra 5, and an extra 6 if you are using union all. Do we understand? Do we all understand what we've done so far, what we've done today? Okay, so we are done with set theory. So let's quickly, with the little time that we have, let's just quickly explore some of the questions that you guys dealt with. Let's just quickly explore some of them before our time is exhausted. Hope you guys are on the same page with me. I don't want to assume that everyone is on the same page, but I hope everyone is following. Okay. I like the fact that I think Dorcas is always following. It's interesting. And DG is really active today, and I like that. So you see, as you watch those recordings, as you practice, as you make up your mind that you are going to learn, honestly, you will learn. There is no jazz. It might just take time. There is no enchantment that will stop you from learning. As long as you've made up your mind and you put the effort. So quickly, let's list. Okay, so what is going on now? Haba, what is this? What did I just do, for goodness sake? Where is this supposed to be now? Hold on, let me look for it. Week 3 assignment. Is this it? Hopefully this is it. Okay, week 3 assignment. Okay, this is it. So yes, just 3 people have turned in theirs. I don't even know if I should do this. Just 3 people have turned in their assignment, and it's not encouraging, honestly. 15 people have been assigned. 15 people out of 15, just 3 people. I know that we are very busy, but please take time to work on this. Now, somebody said I'll get back to us on this one. I'll ask Mr. Nandi and Austin College DB. But this one that they said you guys should answer, list the names of all artists in alphabetical order. This one is very cheap. You can just do select, let me just say star. Okay, let me just do select star from artist first, just to see what we have on the artist table. Select star from artist, and I'll run this, and you can see, in fact, it is even in it is already in alphabetical order already, just doing this alone. But then let's just select the name alone. I mean, this is already in alphabetical order. I don't know what there is to order again. You can leave it like this, or if you're not contented, you can do order by name, and you can do ASC, I think. Let's see if this will even work. Order by name. Now what's going on? What's going on? Oh, something pressing on my keyboard. Okay. So name. So from let's see if this will work. I don't know. Oh, okay. Hold on. Oh, wait. Let's see. Because I think this thing just changed. Oh wow. So using this even changed the whole thing. Wow. So please use your order by. Look at this. When we used order by name in ascending order, look at the results. Look at the effect. Look at the effect. The whole thing changed. I mean, look at this. The whole thing changed. It really changed. So please use your order by. That's why I always go all the way. I don't assume. I just make sure that I check everything. So if it's the same thing, fine. But if it gives me different results, I check to see which one best communicates the question and the answer to the question, and then I choose. So you should always do the same. Check and check. Make sure you vet your code. No matter how good you are, always vet your code. So what is the name of the composer with the highest number of tracks that have the have the word love in their title? Okay. the name of the composer. So let's see, select star, let's say from, I don't know which table has that information. Let me quickly check our tables. Let me see my database structure, playlist, playlist track, the track. Okay, the track is the one that has the composer column. So let me quickly check track. Hope you guys are seeing how I'm doing this. You're seeing that it's not like I know everything in my head. I'm also checking one by one. I'm checking to be sure. Guys, are you with me? Yeah, so it's important that you are following because I have to check too. I don't, it's not like I have everything downloaded in my brain. So I have to check so I can see, okay, the track has the composer. And another thing is composer with the highest number of tracks that have the word love in their title. Okay, tracks, the name. Now look at this, the name. Okay, so I'm going to say first I'm going to say select. I'm just going to say select composer first, just composer first. Let's just say composer comma name first, and then I'll just say from what's it called, the track table, and then I'll say where name, where name, like I've forgotten how to even use like, where name is like I'll use my this guy here. I hope this is correct. It's been long since I used this thing, my goodness, like love. And I use this and then I run this. So let's see how this goes. Track, let's see. Okay, so this is correct. That has, okay. Okay. So we do not have composer ID, but we have a composer table, right? We don't have a composer table. In fact, we don't have anything that has to do with composer table, but we are sure that the composers are different. The composers are different, and some of them are even empty. We don't know who they are, and the job of the count is to eliminate such. The count will eliminate those places. I'm not sure. Let's see. We want to see again, what does our question say? It says the name of the composer with the highest, the name of the composer with the highest number of tracks that has the word love in their title. So definitely we are using count. We are using count. Let's just use count name. Let's use count name, or let's use count track ID instead. Count the track ID. We're counting the track ID, and we want to group by the composer. You can group by the composer. Let's see, group by composer. Group by composer. So we want to see those composers and how many tracks. Okay, so look at this. Null. Can you see this? Can you see this, guys? You can see the null. So let's see. So you can see those guys that have, okay, so null automatically has unknown. There is someone who is unknown. Let me see if this will work. I'm not sure if this will work. There is a function called coalesce, and coalesce helps you to replace null with something. Let's see if I use unknown. Let's see if I use unknown. Let's see if this will work. I'm not sure. Let's see. So I'll execute and boom. Okay, very good. So instead of null now, we have unknown. We have unknown. We have unknown, and then we can begin to even, we can say order by the count of the track ID. Count of the track ID. Let me use this. count of the track ID. Okay, so let's see how this goes. And descending order, DESC. Let's see how this goes. Okay, so observe, guys. So unknown, we don't know who this person is, right? We don't know who this person is. Let me use as composer. Let me use as composer. We don't know who this person is, so we give the person unknown. And then for the count, let me just use number of tracks. Number of tracks, so I can easily make sense of what I'm looking at. So I gave this unknown. I can give it a different name also. So the job of the coalesce is to replace anywhere you have null values in a particular column. The coalesce is just going to replace it with whatever value you specify. Whatever value you specify, that's what to replace it with. But whatever value you are going to specify, you have to ensure that it is of the same data type as your column. So whenever you are using string, you know, this is a string, a column that contains text, right? Contains text, so make sure that you're using text also here. So just look at this. We have unknown, we have this person here, and we can just limit. If we limit, because it's asking for the highest, the query says the highest, so I can run this and we'll have just unknown. And if I limit to 2, I'll have unknown and then u2, this person 4. So this is one way to do it, although I don't think that this null. Let's look at a scenario where we get rid of the null, that is no coalesce. We're not using the coalesce function. We just have our good old composer column, and let's see how this goes. So we have the composer again. If you look at this, we still have null. Are you guys seeing this? Please, do you guys understand what we are doing? Do you understand what we are doing? Okay, Chidima is following, Latif is following. Are you guys with me, please? Are we on the same page? Nobody to respond.
Sorry, Mr. Bennett.
Yes?
So the thing I noticed actually is where the result is coming out from is actually small. So we don't, like me, I don't see the values that come out. It's just that because I'm following, so I am assuming I'm correct. But I don't really see what comes out.
It's because that's how they designed this thing actually. There's no way to even zoom it in.
Yes, I understand.
When you are watching the recording, you will see it. It will be clear when you are watching the recording. That's why I always record my entire screen, so that you see every single thing I am doing and the outputs. So I'm sorry about that. There's nothing we can really do. Okay, so now, yes, one last thing. Instead of using this null, instead of including null in the mix, we can get rid of null. How we will do that is we'll specify a condition again, same where clause, where name is like love, and we'll say composer is not null. I think this should work. I'm not sure. Let's see. If we run this now, observe. So everywhere it saw composer as null, this condition here, composer is not null, it eliminates it immediately. Everywhere, every single place. Okay, so the meeting will end soon. But guys, are you following? Do you understand this? Do you understand what we did here? So if I remove the limit to 1, I can easily just run this instead, and boom, I just have okay u24. So guys, this is like, if you are unsure, it's important that you run like different scenarios. So whoever gave you the assignment can always take a peek, choose whichever one he or she wants. Sure, you get. It's important that you are flexible enough to test all of these things. So let's see if we can take on one more question before we call it a day. Which customers made purchases on July 4, 2013? This one might be quite tricky. Which customers made purchases on July 4, 2013? Okay, let's see. Quickly, let's see. We'll do select star from. Already we know that it is invoice. Invoice has the dates these purchases were made, and it has the customer ID, so we can do with this first. So the invoice date, okay, that's what we work with. So let's see what the date column looks like first. Let's say invoice date equals, let's see, July 4 2013. Let's say we use this, and then we say 2013. Remember, it uses the year, month, and day syntax. 07, and then we use 04. So let's see how this goes. Let's see if it will return actual values. Let's see. Okay, look at this. It's not returning anything. Let's check the date again. July 4, 2013. Okay, so this is quite interesting. Let's see if I use a date function on it. Let's see if I use a date function on it. Let's see if it will work. Still nothing. So two things are happening here. Is either it does not exist, or it is still this issue. Hold on. Okay, so there is a possibility that there is no purchase on 20, but let's see. I'm not sure just yet. Does someone want to say something?
No, yeah, Mr. Gumi, I feel that Chidima should come in here, because there was a time she was actually asking this question in the group.
Okay.
That is as if it did not get to the year.
No, if
it's
you get
not up to that year.
Okay, Chidima, were you able to make progress with this? Were you able to do it, get it done? Were you able? Is Chidima still here? Chidima. Okay, Chidima is here. Quickly, we have just 2 minutes left. Let's see. But were you guys okay? Not everyone has even submitted this thing. Not everyone has submitted it. So I don't want to use 0000. But let's see. I doubt that this is the case. But let's see. Let's see if this will give any difference. If it will make any difference. Okay, still the same thing. Let me use date again. Still the same thing. Okay, so even if this does not work now, I'll still work on it. But then I can't easily just send in the correct query because others have not submitted. So it is your duty to research on this, find out what we can do to solve this problem. You have to find out. So guys, this is the end of today's class. We've been able to cover a whole lot of things, and I hope you guys were able to learn. Like I always say, you have to come ready, you have to come prepared, come to learn, and I hope you guys did just that. Like I said before, this might be our last live session, at least for me, at least with me. I don't know if that's the case. But if that's not the case, it's all good. Even if that's the case, it's all good also. I appreciate your commitment to your learning, and please submit your assignments. So this is it for today, guys. Well done. Yeah. So the meeting has ended. All right. So take care, guys. Thank you for your attention. Thank you for joining when you were supposed to join. Well done. I celebrate you all too. I celebrate you all. All right, guys. Bye.